So basically, every non-quadrantal angle in standard position will have a positive acute angle known as its reference angle. So the reference angle for our angle, let's just call it theta, is going to be normally written as theta prime. So you'll see theta prime like this to denote the reference angle. So this is a positive acute angle that is made by the terminal side of our angle theta and the x-axis. So it's always the x-axis. You don't want to get confused and use the y-axis. And I'm going to give you a simple little formula based on what quadrant you're in, okay? You just write down the formula and use it. It's very, very simple. So if you're in quadrant 1 in terms of your terminal side, so if you had an acute angle, again in standard position, theta prime will be equal to theta. Okay, so if you were in quadrant 1, then you can say that theta prime is exactly equal to theta. So we don't need a diagram for that. If you're in quadrant 2, okay, then theta prime is going to be equal to 180 degrees minus your angle theta. Okay, so we can see that with this example here. So here our terminal side lies in quadrant 2. So we have this angle here theta, okay, and that's the measure there. But then we have this angle theta prime. So you can see that from the terminal side here to the x-axis is our angle, and we're calling this theta prime, okay? So I want you to notice something here. If we had the terminal side lying completely on the x-axis, so if it lied like this, that would be an angle of measure of 180 degrees. It's a straight angle. So I would have 180 degrees there. If I subtracted away this part right here, my angle theta, okay, I would have the measure of my angle theta prime, okay, my theta prime, because these two would be supplementary angles. They're two angles that have measures that sum to 180 degrees. All right, what about in quadrant 3? Okay, our formula is going to change up a little bit. Well, you'll notice that you have this angle here, theta, and this is greater than 180 degrees now, okay? And this is your angle theta prime, okay? This is your angle theta prime from the x-axis to your terminal side. Well, okay, you have these two angles here, and essentially the measure of angle theta, if I subtracted away this angle here, this straight angle that's formed, I would be left with exactly the measure of theta prime. So I can do the measure of angle theta minus 180 degrees, okay? And this will give me my theta prime in this situation. All right, now lastly, if our terminal side is in quadrant 4, okay, all we need to do in this particular case, since I'm coming from here and going there, so from my terminal side up to the x-axis, what I want to do here is I want to take and say theta prime is equal to what? Well, one complete rotation, if I went all the way around, okay, all the way around, that would be 360 degrees. And I want to now subtract away just this part right here. So this part right here, okay, this part right here, that, if I subtract that away, the measure of angle theta, that's going to give me this part right here, which is my theta prime, which is what I'm looking for. Let's look at a few examples. So let's say I had a 330 degree angle. How would I find the reference angle? Well, the first thing you want to do is you want to think about what quadrant is it in. And in this particular case, we'd be in quadrant 4, okay? So if I'm in quadrant 4, then what I want to do is I want to say 360 degrees minus the measure of this guy, minus 330 degrees, which would give me 30 degrees. Okay, so 30 degrees would be my reference angle in this case. So I drew a little diagram so we could look at this. Again, this part right here, this is a 330 degree angle. Okay, so you can just think about what's left to get to the x-axis. Well, I would have another 30 degrees to go, and so this would be my reference angle. Okay, so 330 degrees for the original angle, and then another 30 degrees to make a complete rotation and get back to that x-axis. So that's your reference angle in this scenario. All right, for the next problem, we have negative 250 degrees. So if you get an angle that's negative, or one that's greater than 360 degrees, what you have to do first is find a coterminal angle between 0 degrees and 360 degrees. So the first thing I'd want to do here is add negative 250 degrees and 360 degrees, okay? Remember, coterminal angles are angles in standard position that have the same initial side and the same terminal side, okay? So we're going to lie in the same quadrant by doing this. So if I add these two together, I am going to end up getting, and let me just slide this down just a little bit, I'm going to end up getting 110 degrees as a result. So a 110 degree angle is going to be in your second quadrant, okay? So what I want to do here is just do 180 degrees minus 110 degrees. And so my reference angle would be 70 degrees, okay? So very easy to do once you have your formulas. And again, I'll show you this with a diagram. You have your 110 degree angle, or you could also do this as a negative 250 degree angle, okay? Same thing. And basically, you're looking at your reference angle as coming from here going down to the x-axis. Again, if you erase this and just think about it in terms of the coterminal angle, then if I'm here at 110 degrees, okay, if I'm here at 110 degrees, well, how much more do I need to go to get to the x-axis? Considering if I got to the x-axis, I'd have a 180 degree angle. Well, it's another 70 degrees, so that's the measure of my reference angle. Okay, so let's look at one more of these, and then we'll move on. So now I have a 560 degree angle. Again, if your angle is greater than 360 degrees, or if it's a negative angle, you've got to first find a coterminal angle that's between 0 degrees and 360 degrees. So let me just go ahead and say I'm going to subtract 360 degrees away, and that's going to give me exactly 200 degrees, okay? And so that angle there, that coterminal angle, would lie in quadrant 3. So in this particular case, I'm going to take the measure of this angle here, the 200 degrees, and I'm going to subtract away 180 degrees, and that's going to give me 20 degrees. So that's my reference angle. So if we look at the diagram here, again, if you thought about a 560 degree angle, you would have one complete rotation, okay, and then you would come back to this point. That would be 560 degrees. But again, we just used the coterminal angle, okay? So we use the angle with a measure of 200 degrees. So I've got to go 200 degrees to get to that point there. Well, how much do I have to go back up to get to the fact that I'll have a straight angle, right? A straight angle is 180 degrees. Well, I need to go back up 20 degrees. But again, this is going to be a positive angle, so we think about it going counterclockwise from the x-axis down to your terminal side. So again, that's how we get that reference angle of 20 degrees.